Alright, everybody. I'm going to go over the configuration for an IPv6 configuration on a router. As you can see, I got two 2691 routers connected in GNS3. I just kind of got over doing a brief IPv6 overview myself, so this is kind of me sharing my new skills with you. As we all know, IPv6 is 128-bit IP addresses that is going to probably be taking over the internet rather soon. Migrations are already starting to happen, and this is just going to be a really basic overview on configuring it. So as we get started here, I'll go ahead and turn on my headquarters router, and once that powers up here, I'll just go ahead and console into that. And then my little terminal window pulled up here. It should actually be. Go ahead and get another tab open for that. 2001. Cool. So now from here, I'm going to go ahead and console into the router, waiting for the login prompt to show up here. It's taking its sweet time, of course. Alright, there we go. So it just took its sweet retarded time. But as I get into the configuration here, so as you can see, I just put it out on Notebook. So this looks really short compared to what an IPv6 address looks like. Each, well, and they don't really call it alt-tag, but each, I call it alt-tag, has four sets of numbers. This is actually a hexadecimal representation, so this is actually showing 16 bits worth of data, with each number representing 4 bits of data. So do your math. Obviously, 4 times 4, 16. So, yeah, with that said, we'll go ahead and go into router 1, and we'll configure the host name line just to make things easier, and then I'll do my line. That up, console 0, login synchronous, just so we don't overlap console messages. And so let me turn on my interface labels, and we'll see that this interface here is actually fast Ethernet 00, going to this Ethernet switch, fast Ethernet 00. The Ethernet switch is configured with no VLAN, everything's all in the same default VLAN 1, so we'll be able to communicate that way. Now back to the router. We'll go ahead and go fast Ethernet 00, like I said before. And you know what before, which is verifying, show IP interface brief to see, the interfaces, but we're going to go into fast Ethernet 00. And then from there, we're going to assign the first IP address. Now, kind of back to what I was saying, that IP address is really shrunken down. There are some rules that you can do with IPv6 to make what is 128-bit address look like this, but I'll show you. So this, increase my font there. No, I don't want to do that. Okay. So this address is actually representing this address here. So what this ends up saying is this is 2001 : in IPv6 there's two rules. You can drop the leading zeros off an address per octet, or if you have grouping of zeros, that can be represented by double colons, which this does. So back to my notepad here, and I can show you what I mean by that. So what this address really reads out in the IPv6 full notation would be 2001, 1000, or 2001, or 2001. It's not really 2001, but 2001, 0001. Now, you realize that this 001 is actually removing those two leading zeros, like I explained before. Now you see we have 1, 2, 3, 4, 5, and then, well, 5 groups of zeros. Well, this is what this represents. So the router, I don't know how it does it, but it knows that this double colon knows that the IPv6 address is 128 bits. So this double colon will represent whatever octets are left in the address. It knows to fill that in with zeros to get you up to that 128-bit address. But just like any network address, there's a subnet and there's a host bit. In this example, I'm going to be using a 64-bit net mask, which means the first 64 bits is going to represent a network. And if you do the math, like I said, each octet is 16 bits, so 16 times 4 will get you your 64 bits, and that's actually my network portion. So this would be my network portion, and then the remaining 4 octets would be my host portion, with this being my address, my host address. So that just kind of breaks down what this is, how IPv6 kind of breaks down. If you don't have a lot of experience on it, I would suggest going and looking on YouTube to a few IPv6 videos, and it'll go a little bit in depth, but to the sense of this video, I'm going to anticipate that you know a little bit about IPv6 addressing, and this is more for configuring it on a Cisco router. So from there, I'm going to go ahead and do IPv6, and we're going to add address. Now, what's pretty cool about IPv6 that you can do is instead of having to type this entirely long address here, I can type this address, and it knows that it means this. So what I'm going to do is I'm going to type in 2001:01:64. And what that does is it accepts it and it takes it as the IP address. So if I take it as an end show IPv6 interface brief, you see that it makes this address assigned. This here is actually your link local address. This is the IP address that talks to your local segment. Like I said, if you don't have a lot of experience with IPv6, I would definitely go and look into a couple videos or read some literature on it, but because it gets pretty in-depth and it's a different beast when it's dealing with IPv4 when it comes to actual networking and address allocation. So, and address usage, let me say that much. So yeah, I would definitely recommend doing that. So now we're going to go ahead and go into my interface again, because as you can see, I have it administratively shut down. So I'm going to go ahead and configure T interface FA00, and I'm going to do a no shut on that. So that interface should come up here shortly. And if I do a show IPv6 interface brief, you'll see up and up. So the HQ router is good. And now we're going to bring up the branch router. And this is going to be running on the same subnet, but just the second host address. And once again, we look at it on Notepad. We see this. This is my network. This is my host portion. This is my unique host address for branch 1. So when branch 1 boots up, I'm going to log into that router now and then configure its interface to run IPv6. It's kind of the same thing, just waiting for it to come up now. And when this shows up, well, it takes a little second. I don't know why my 2691s are running retardedly, but for some reason they are. But there we go. So we got my prompt coming up here, and I'll just do the normal. Gonna set up my host name. Just put config 2 in there. Host name, we're gonna call this branch 1. And we're gonna go into line console 0, login synchronous, and do get out of there for console messages. and then FA00, and then same thing, IPv6 address. We're going to do the same 2001. And you know what? And this time, what I'll do is I'll paste this as if we were going to write it up a long way, and the router should still take the address, and it should chop it down to look like this. So let's see. So I'm going to take that address. I got to put my /64, and you see it took it. So if I do a show IPv6 interface brief on my branch router, like I said, it's going to chop it down to where it's that nice readable format, but at the end of the day, it's the same address. It's just, I don't know who, I want to call it Ian or whoever made the standards way of making it easy for us to work with. Because I'll tell you one thing, getting used to this, it's a little bit of a pain, but hey, what, learning a new subject wouldn't be fun if you didn't have challenges. So we're going to do a show IPv6 route, which actually shows my routing table for my IPv6 router. You can see directly connected, showing metric of 0, or metric of 0, administrative distance of 0, obviously. But what I can do now is I can ping my .1 address from my branch router and be able to get connectivity. So if I ping IPv6, and then I'll do 2001:01:1, and I should get a successful ping, in which I did. So as you can see, IPv6 really is not that difficult. It's a different beast when it comes to actually learning, well, implementing, let me say that much. But it's pretty cool once you start getting into it and learning about the functionality of the addressing. And to me, subnetting, it seems a lot harder because it's a bigger address, but honestly, you're working in hexadecimal, and you know that each, octet, let me close iTunes out, but you know that each octet is 16 bits each. So, whenever you get a /64 or /32 or /whatever the case is, you already know how to, it'll be easier for you to count that out. So that's just one of my, pluses in IPv6, and I have many more studies to go. But that's just basic connectivity between our IPv6 devices. Well, thank you guys for listening, and see you next time.